Here's one more example. I'm going to get it started. It's a little bit different looking, where we want to FOIL out this x minus 3 all squared. Because we have an x minus 3 and an x minus 3. And then it's greater than or equal to 1. So we're going to FOIL these two parentheses together. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And then we still have on the right, greater than or equal to 1. Now I'm going to combine like terms. Here are my like terms, negative 3x and negative 3x combined to negative 6x. And then we still have x squared plus 9. Now let's bring that minus 1 to the left side. So we're getting it into standard form. Now combine like terms, 9 minus 1 is 8. Now we have it in standard form and we want to factor it. Remember in our rules of factoring, this is a trinomial, the leading coefficient is 1. So we want to use the chart method of factoring. So maybe off to the side, you'd say, what are the factors of C, which is 8, that add to B, which is 6? So you list off all the different factors of 8. Well, one of them is 4 times 2 is 8. And they add together to give you 6. So these are the numbers we're going to work with, 4 times 2. So we split up this trinomial into two factors, into a binomial times a binomial. X squared becomes x and x. And then here's my 4 and 2. Positive 4, positive 2. Now we identify the critical points from this factored inequality. We set each of the factors equal to 0 and solve for x. We get x plus 4 equals 0 and x plus 2 equals 0. And now we solve for x. So we subtract 4 and we subtract 2. So these 2 points, negative 4 and negative 2, are called my critical points. Then we would set up those points on a number line and create our test intervals. So here's 0, and we have negative 2 and negative 4. Our critical points are at negative 4 and negative 2. So our test intervals are going to go from negative infinity to negative 4. So negative infinity to negative 4 is one test interval. Then we have another test interval from negative 4 to negative 2. And then our last test interval is from negative 2 to infinity. And then we would pick a point in those intervals and plug it into the original inequality and see which one is true, and those will be our solutions to this quadratic inequality. We've done that a couple other examples already, so I think I'm going to skip that.